Right now, you are moving through space at tens of thousands of kilometers per hour. And yet, you feel perfectly still. The sun is whispering. The planets are turning in silence. And some worlds have been waiting in the dark for billions of years. This is not a video of loud facts. These are the universe's softer truths. As your eyes grow heavy, the solar system begins to speak in whispers. Take a slow breath and drift gently into the space between the stars. Hello, and welcome to Dreamy Science Stories. I'm really glad you're here. Maybe today felt long and heavy. Or maybe you're someone who finds comfort drifting among distant planets and quiet moons instead of counting sheep. Either way, tonight is just for you. You don't need to focus on anything now. Let your breathing slow. Let your thoughts soften at the edges. Feel your body grow lighter, as if gravity itself is easing its hold, and you've begun to float gently through space. Because tonight, we're taking a slow journey through the solar system. Not rushing, not following straight lines, but drifting in wide, gentle curves, past glowing planets, dusty rings, shadowed craters, and frozen oceans hidden beneath ice. This is a story told without equations or pressure. A story of magnetic storms, tilted worlds, backward suns, and moons that shine quietly in the dark. From sideways planets to falling diamonds, from ancient sunlight still traveling the void to worlds shaped by silence and time, each orbit carries something strange and beautiful. We'll move slowly, one calm fact at a time. And before we begin, if these quiet explorations help you relax or give you a peaceful way to end your day, you're welcome to gently like the video or subscribe. It helps other sleepy minds find their way here too. Now, let's begin. Neptune's winds move faster than sound. Far beyond Earth, in the cold outer reaches of the solar system, Neptune is anything but still. Despite its distance from the Sun, it hosts the fastest winds ever recorded on a planet. These winds race through Neptune's atmosphere at speeds over 2,000 kilometers per hour, faster than sound travels on Earth. That's several times faster than a jet aircraft. Scientists believe this extreme weather is powered by heat rising from deep within the planet, slowly escaping into its icy blue atmosphere of hydrogen, helium, and methane. It's a frozen world in constant motion. Quiet, violent, and endlessly swirling. Mars holds a canyon that spans a continent. Stretching across the Martian surface is a vast scar known as Valles Marineris. It runs more than 4,000 kilometers along the planet's equator. In some places, it drops over 7 kilometers deep, far deeper than Earth's Grand Canyon. If placed on our planet, it would stretch from coast to coast across the United States. Unlike Earth's river-carved canyons, this enormous rift likely formed as Mars's crust cracked, shifted, and pulled apart long ago, shaped by tectonic stress and volcanic forces. Today, it lies silent, a frozen memory of a restless planet. Venus has no global magnetic shield. Although Venus is similar to Earth in size and composition, it lacks one critical protection, a strong magnetic field. Earth's magnetic field is generated by the motion of molten metal deep in its core, forming a shield against harmful solar radiation. Venus, however, appears to have a core that moves too slowly, or not at all, to create this effect. Without protection, the solar wind has gradually stripped lighter elements from Venus's atmosphere. Over time, this helped transform a once potentially Earth-like world into an overheated furnace. A reminder that small differences can shape entire worlds. Diamonds may fall like rain on distant planets. Deep inside Uranus and Neptune, pressure and heat reach unimaginable extremes. Within these icy giants, methane-rich layers may break apart under force, releasing pure carbon. Scientists believe this carbon can compress into tiny diamonds that drift downward like glittering rain, falling toward the planet's cores. Laboratory experiments have recreated this process on Earth, turning hydrocarbons into diamond dust under extreme conditions. If true, storms of diamonds may fall endlessly through dark blue skies, unseen and silent. Earth is unique for its moving plates. One of Earth's most life-shaping features is plate tectonics. Massive slabs of crust slowly slide across the mantle, colliding, separating, and recycling material over millions of years. This movement builds mountains, triggers earthquakes, and regulates carbon levels that help stabilize climate. So far, no other planet shows clear evidence of this system. Mars and Venus have cracks and volcanoes, but their surfaces appear largely frozen in time. Earth's moving plates may be one reason life was able to flourish here for so long. Some asteroids have companions of their own. Asteroids are often imagined as lonely travelers. But some have moons. These small satellites may be captured fragments or partners formed together long ago. The first known asteroid moon, Dactyl, was discovered in 1993 orbiting the asteroid Ida. Since then, scientists have found dozens more asteroid moon systems, including pairs where two objects orbit each other like a quiet cosmic dance. Even the smallest bodies in space can form relationships, bound by gravity. Mercury wears a ghostly atmosphere. Mercury doesn't have a true atmosphere like Earth's. Instead, it's surrounded by an extremely thin exosphere, a near vacuum of scattered atoms. These particles come from the planet's surface, knocked free by solar wind and tiny impacts. Sodium, potassium, and oxygen drift briefly before escaping into space. Because Mercury's gravity is weak, this fragile envelope must constantly be renewed. A faint, invisible shimmer clinging to a sun-scorched world. The sun slowly gives itself away. Every second, the sun converts millions of tons of its own mass into energy. Deep in its core, hydrogen atoms fuse into helium, releasing light and warmth that reach across the solar system. This steady sacrifice powers Earth's winds, oceans, and life itself. Though tiny compared to the sun's total size, this loss adds up over billions of years. One day, the sun will change. But for now, it continues its quiet burning, giving endlessly. Saturn's rings will not last forever. Saturn's glowing rings look eternal, but they are slowly fading. Ice particles and dust are drifting inward, pulled by gravity and guided by the planet's magnetic field. This process, known as ring rain, means Saturn's rings may be relatively young and may disappear entirely in the distant future. A reminder that even the most beautiful structures in space are temporary. Ice survives on a world scorched by sunlight. On one of the hottest planets, where sunlight burns relentlessly, water still exists, frozen and hidden. Scientists believe this ice may have arrived long ago, delivered by ancient comets or released through volcanic outgassing. Deep inside shadowed craters near the poles, sunlight never reaches. Crater walls block the heat, creating permanent darkness where ice can remain untouched for billions of years. Even in extreme environments, nature finds a way to preserve what seems impossible. Pluto may conceal a hidden ocean. Far beyond Neptune, Pluto holds a quiet mystery beneath its frozen surface. Its bright, heart-shaped region, called Sputnik Planitia, is more than a beautiful landmark. Data from the New Horizons spacecraft suggests this massive basin may rest above a subsurface ocean of liquid water. The weight of the region, combined with signs of slow geological motion, hints at a slushy, convecting layer beneath the ice. If such an ocean exists, it may be kept warm by radioactive heat deep inside Pluto and insulated by thick layers of ice above. Even in the coldest reaches of the solar system, liquid water may quietly endure. The asteroid belt is mostly empty space. Despite how it's often shown in movies, the asteroid belt is not a chaotic minefield of flying rocks. In reality, it's vast and surprisingly sparse. Located between Mars and Jupiter, it contains millions of rocky objects, but the distances between them are enormous. A spacecraft could pass through without encountering a single asteroid. Altogether, the entire belt holds less than 5% of the Moon's mass. Most of that comes from just a few large bodies like Ceres and Vesta. The rest are ancient fragments, unfinished pieces of a planet that never formed. Uranus rolls around the Sun. Most planets spin upright, slightly tilted like spinning tops. Uranus does not. With an axial tilt of about 98 degrees, Uranus lies almost on its side, rolling along its orbit rather than standing upright. As a result, each pole experiences decades of continuous sunlight, followed by decades of darkness. Each season lasts more than 40 years. This extreme tilt may have been caused by a massive collision early in the planet's history. Whatever the cause, Uranus remains one of the strangest worlds in the solar system. Jupiter's radiation is lethal. Jupiter is wrapped in the most powerful magnetic field of any planet. Within it lie radiation belts so intense they could destroy unprotected spacecraft. These belts trap charged particles, forming regions far stronger than Earth's Van Allen belts. Even Jupiter's moons are constantly bombarded, altering their surfaces and affecting their potential to host life. Spacecraft that venture near Jupiter must use heavy shielding or carefully planned paths. It is a breathtaking planet, surrounded by invisible danger. The Sun holds almost everything. At the center of the solar system, the Sun dominates not just with light, but with mass. It contains more than 99.8% of all the material in our planetary neighborhood. Everything else, planets, moons, asteroids, comets, makes up less than a fraction of a percent. This immense mass generates the gravity that keeps worlds in orbit and fuels the nuclear fusion at the Sun's core, turning hydrogen into helium and releasing energy across space. Every sunrise begins there. There may be more dwarf planets than planets. Beyond Neptune lies a vast population of icy worlds. Pluto is only the most famous among many. Others, like Eris, Haumea, and Makemake, orbit quietly in the Kuiper Belt and beyond. Many more candidates have yet to be fully identified. These small, spherical bodies are ancient relics from the solar system's formation, largely unchanged for billions of years. Though distant and cold, they carry the earliest stories of how everything began. A day on Venus lasts longer than its year. Venus rotates incredibly slowly. One full spin on its axis takes 243 Earth days. Yet it completes an orbit around the Sun in just 225 days. This means a single sunrise to sunrise day on Venus is longer than an entire year. Combined with its thick atmosphere and crushing pressure, this slow rotation helps trap heat, creating surface temperatures hot enough to melt lead. Venus is a world of endless heat and slow-burning time. Titan has rivers of methane. Saturn's moon Titan is the only other place in the solar system with stable liquid on its surface, besides Earth. But on Titan, those liquids are methane and ethane. Lakes, rivers, and seas carve the landscape under a thick nitrogen-rich sky. Methane rain falls, clouds gather, and seasons change. Beneath its icy crust, scientists believe Titan may also hide a vast ocean of liquid water. It is a familiar world built from unfamiliar chemistry. Mars's moons may be captured wanderers. Phobos and Deimos are small, irregular moons that look more like asteroids than traditional satellites. Their shapes, compositions, and orbits suggest they may have been captured by Mars long ago. Another theory proposes they formed from debris after a massive impact. Phobos is slowly spiraling inward and will one day break apart or crash into Mars. Deimos drifts quietly away. Two tiny companions, marking the passage of time. Jupiter shines from within. Unlike most planets, Jupiter emits more energy than it receives from the Sun. This heat comes from deep inside, leftover warmth from its formation and slow gravitational contraction. That internal energy fuels its massive storms and colorful cloud bands. In infrared light, Jupiter glows like a smoldering ember beneath its clouds. It is not a star, but it almost became one. Neptune was discovered with mathematics. Before anyone saw Neptune through a telescope, it was found on paper. Astronomers noticed strange irregularities in Uranus's orbit, tiny deviations caused by an unseen object. Using mathematics alone, scientists predicted where that object should be. When telescopes were aimed at the calculated position, Neptune appeared. It was the first planet discovered through numbers before light. Saturn's North Pole has a hexagon. At Saturn's North Pole, a massive six-sided cloud pattern spins endlessly. This hexagon spans more than 30,000 kilometers, wider than Earth itself. It has remained stable for decades, possibly centuries. Scientists believe it forms from the interaction of rotating atmospheric currents and standing waves. Few sites in the solar system feel more precise or more surreal. The Sun's atmosphere is hotter than its surface. The Sun's visible surface is about 5,500 degrees Celsius. But its outer atmosphere, the corona, reaches temperatures over 1,000,000 degrees. This mystery has puzzled scientists for decades. Magnetic waves and tiny explosive events called nanoflares may transfer energy upward, heating the corona beyond expectation. Even our nearest star keeps secrets. The Kuiper Belt is a frozen archive. Beyond Neptune lies a vast ring of icy objects known as the Kuiper Belt. It stretches billions of kilometers and contains countless remnants from the solar system's birth. Some are dwarf planets. Others are irregular fragments drifting through the cold. It is a fossil zone, a preserved record of ancient materials. The Oort cloud may extend nearly a light-year away. Far beyond the Kuiper Belt lies the hypothetical Oort cloud, a distant shell of icy bodies surrounding the solar system. It may stretch nearly a light-year from the Sun and is believed to be the source of long-period comets. These objects are only loosely bound to the Sun. A passing star can send one drifting inward after millions of years of silence. If it exists, the Oort cloud marks the true edge of the Sun's influence. Io is the most volcanic world known. Jupiter's moon Io is in constant turmoil. Its surface erupts endlessly with molten sulfur and rock. This extreme activity is powered by tidal forces. Io is squeezed and stretched by Jupiter's gravity and neighboring moons, generating intense internal heat. Its surface is young, unstable, and always changing. A moon with a molten heart. Triton moves against the flow. Neptune's moon Triton orbits backward, a retrograde path that sets it apart. This suggests it was captured long ago from the Kuiper Belt. Triton shows signs of cryovolcanism, with icy plumes and a thin atmosphere that changes with the seasons. Cold, distant, and moving in reverse, Triton defies expectation. Earth's moon is unusually large. Compared to its planet, Earth's moon is enormous. No other rocky planet has such a large companion. Most scientists believe it formed after a massive collision early in Earth's history, when debris coalesced into a single body. This partnership has shaped Earth's tides, climate, and stability for billions of years. The moon is not just a companion, it is a legacy. Planetary orbits are gentle ellipses. Planets don't travel in perfect circles. Their paths are slightly stretched, forming ellipses. Each orbit has a closest point to the Sun and a farthest one, subtly affecting speed, sunlight, and seasons. This elegant motion was first described by Johannes Kepler, reshaping humanity's understanding of cosmic order. Some comets come from the edge of the Sun's reach. Long-period comets may originate in the distant Oort cloud. They travel vast, elongated paths and appear only once every thousands or millions of years. Dislodged by passing stars or galactic tides, they fall inward, briefly lighting our skies before returning to darkness. Ancient messengers from the solar system's edge. When comets drift inward, they briefly ignite the sky. As ancient comets fall toward the Sun, they awaken. Ice turns to vapor, dust lifts away, and glowing tails stretch across space, sometimes visible even from Earth. Many of these visitors may have spent billions of years wandering in complete darkness before gravity nudged them inward. Their sudden brightness is temporary, a short-lived reveal of some of the oldest, most untouched material in the solar system. They arrive quietly and disappear just as softly. The Sun will one day become a white dwarf. Like all stars, the Sun has a limited lifetime. In about 5 billion years, it will exhaust the hydrogen fuel at its core. As fusion slows, the Sun will swell into a red giant, expanding outward and engulfing the inner planets. Later, it will shed its outer layers into space, forming a glowing planetary nebula. What remains will be a white dwarf, an Earth-sized core made mostly of carbon and oxygen. No longer producing energy, it will slowly cool for trillions of years. A fading ember, marking the quiet end of the Sun's long journey. Mars experiences familiar seasons. Though colder and thinner in atmosphere, Mars has seasons much like Earth. Its axial tilt, about 25 degrees, is strikingly similar to our own. As Mars circles the Sun, sunlight shifts between hemispheres, bringing spring, summer, autumn, and winter. These seasonal changes influence polar ice caps, dust storms, and even atmospheric pressure. Because Mars takes nearly twice as long to orbit the Sun, its seasons unfold slowly, lingering in time. Ganymede is the largest moon of all. Orbiting Jupiter, Ganymede is the largest moon in the solar system, larger even than the planet Mercury. Beneath its rigid icy crust may lie a deep subsurface ocean. Its interior is layered and complex, shaped by ancient geological forces. Uniquely, Ganymede has its own magnetic field, creating faint auroras within its thin atmosphere. Despite its size and structure, it remains silent and dark, moving endlessly through Jupiter's magnetic domain. Pluto sometimes moves closer to the Sun than Neptune. Pluto's orbit is long and highly elliptical. Because of this stretched path, it occasionally travels closer to the Sun than Neptune does. This last happened between 1979 and 1999. Even then, the two worlds never collided or came dangerously close. Their motions are locked in resonance. Neptune completes 3 orbits for every 2 of Pluto's. A precise gravitational dance, stable across time. The Sun's magnetic field flips every 11 years. About every 11 Earth years, the Sun reverses its magnetic polarity. North becomes south. South becomes north. This cycle influences solar activity, sunspots, flares, and powerful eruptions of charged particles. At solar maximum, the Sun grows restless. At solar minimum, it calms. These changes ripple outward, shaping Earth's upper atmosphere, satellites, and auroras. The Sun's magnetism pulses like a slow, cosmic heartbeat. Planetary alignments do not cause disasters. Despite popular myths, planetary alignments do not trigger earthquakes or floods. The gravitational influence of distant planets on Earth is extremely small. Even during rare alignments, their combined pull is insignificant compared to the Moon or the Sun. Alignments are mathematically elegant and visually striking, but physically harmless. A silent arrangement of distant worlds, not a warning sign. Leaving the solar system takes decades. Escaping the Sun's influence is a slow journey. The Voyager spacecraft, launched in the 1970s, took over 40 years to reach interstellar space. Traveling at more than 60,000 kilometers per hour, they crossed planetary orbits, passed through the Kuiper Belt, and continued outward into darkness. They still transmit data. And they carry golden records, sounds and images of Earth, quiet messages drifting between the stars. Earth's magnetic field protects life. An invisible magnetic shield surrounds our planet, generated by molten iron flowing deep within Earth's core. This field deflects charged particles from the Sun, protecting the atmosphere from erosion and radiation. Without it, Earth may have lost its air long ago, much like Mars. Some particles slip through near the poles, creating auroras, curtains of light dancing across polar skies. This magnetic cocoon has quietly preserved life for billions of years. The Moon is slowly drifting away. Each year, the Moon moves about 3.8 centimeters farther from Earth. This gradual retreat is caused by tidal interactions between ocean bulges and gravity. Long ago, the Moon appeared much larger in the sky. As it drifts outward, Earth's days slowly lengthen. Far in the future, total solar eclipses will no longer occur. The sky itself is changing, patiently. Some Kuiper Belt worlds shine like mirrors. In the darkness beyond Neptune, certain icy bodies reflect extraordinary amounts of sunlight. Haumea spins rapidly, shaped like a stretched football and coated in crystalline ice. Eris reflects nearly all the light that reaches it, brighter than fresh snow. These surfaces may have been renewed by impacts, internal activity, or chemical processes. At the edge of the Sun's reach, some worlds gleam silently in frozen light. Enceladus releases water into space. Saturn's small moon Enceladus hides a dramatic secret beneath its icy shell. From cracks near its south pole, geysers of water vapor and ice erupt into space. These plumes are powered by tidal heating, friction caused by Saturn's gravity. Within the spray are organic compounds and signs of hydrothermal activity. Some of this material feeds Saturn's ring, linking Moon and planet in an ongoing exchange. Some asteroids are loosely held together. Not all asteroids are solid rock. Many are rubble piles, collections of stones and dust held together only by gravity. These fragile bodies form after collisions, when shattered fragments slowly reassemble. They can spin strangely, contain empty spaces, and shift under stress. Missions like Hayabusa 2 and OSIRIS-REx confirmed their delicate nature. They are ancient ruins, barely intact. Mercury's core dominates the planet. Mercury is small, but its iron core is enormous, making up most of its interior. This disproportionate structure sets it apart from other rocky planets. Some scientists believe a massive impact stripped away much of its mantle. Others think Mercury formed close to the Sun, where heavier elements dominated. The result is a dense, metal-rich survivor from the solar system's violent youth. Venus has no moons. Unlike Earth or Mars, Venus has no natural satellite. Why remains uncertain. It may have lost a moon long ago, or its slow backward rotation may prevent stable orbits from forming. Whatever the reason, Venus travels alone, wrapped in clouds, without a companion in its sky. Most moons belong to gas giants. Earth has one moon. Mars has two small ones. But the outer planets host vast satellite systems. Jupiter and Saturn have dozens of moons, from tiny fragments to massive worlds like Ganymede and Titan. Far from the Sun, gravity gathers companions more easily. The colder the region, the more moons appear. Hubble observes planets from Earth orbit. Though it circles Earth, the Hubble Space Telescope has captured detailed images of distant planets. It has watched storms on Jupiter, winds on Neptune, and seasonal shifts on Mars. These long-term views complement spacecraft missions, revealing slow changes over time. From its quiet orbit, Hubble watches nearby worlds evolve. Jupiter's Great Red Spot endures. For at least 3 centuries, a massive storm has raged on Jupiter. The Great Red Spot is large enough to swallow multiple Earths. Though slowly shrinking, it remains powerful, with winds exceeding 400 kilometers per hour. Its color likely comes from chemical reactions driven by sunlight. While Earth storms fade quickly, this one persists, trapped in Jupiter's endless turbulence. Neptune radiates internal heat. Despite its distance from the Sun, Neptune releases far more energy than it receives. This internal heat powers the fastest winds in the solar system. The source remains uncertain, perhaps leftover formation energy or slow contraction. Whatever the cause, Neptune is far from dormant. Cold on the outside, restless within. Earth alone holds water in all 3 states. Ice, liquid water, and vapor all exist naturally on Earth's surface. Glacier, oceans, clouds, and rain cycle endlessly through atmosphere and land. This balance is essential for life and shaped by Earth's distance from the Sun, its pressure, and stable climate. Other worlds may hold water, but nowhere else does it flow, freeze, and rise again so completely. On Earth, water never rests. The heliopause marks where the Sun's influence fades. As the solar wind streams outward, it eventually meets resistance. Far from the Sun, it collides with the thin gas and dust that drift between stars. This boundary is called the heliopause. It marks the outer edge of the heliosphere, the Sun's vast protective bubble. Beyond it, interstellar pressure dominates. Voyager 1 crossed this threshold in 2012, followed by Voyager 2 in 2018. While the Sun's gravity stretches far beyond, the heliopause marks the end of its energetic breath, the quiet border where solar influence gives way to deep space. The solar system is moving through an interstellar cloud. Our entire solar system is not standing still. It is traveling through a region known as the local interstellar cloud, a thin mist of gas and dust roughly 30 light-years wide. This cloud is part of a larger cavity called the local bubble, likely carved out by ancient supernova explosions. As the Sun moves through it at about 7,000 kilometers per hour, the heliosphere acts as a shield, deflecting incoming particles. By studying this cloud, scientists learn how interstellar conditions shape cosmic rays, the heliosphere, and even subtle influences on Earth. We are not anchored in space. We are quietly sailing through a galactic fog. Some moons are geologically alive. Geological activity isn't limited to planets. Several moons show signs of internal heat and ongoing change. Io erupts with volcanoes fueled by Jupiter's immense gravity. Enceladus releases plumes of water vapor from beneath its ice. Europa and Ganymede likely hide oceans warmed from within. Even distant Triton shows signs of icy volcanism. These moons are not frozen relics. They are restless worlds, shaped by energy, chemistry, and motion beneath their surfaces. Pluto's atmosphere appears and disappears. Pluto, small and distant, carries a fragile atmosphere made mostly of nitrogen. When it draws closer to the Sun, surface ice turns to gas, forming a thin, hazy envelope. As Pluto moves away, the atmosphere cools and collapses, freezing back onto the surface like frost. This cycle unfolds over Pluto's 248-year orbit. During the New Horizons flyby in 2015, this atmosphere glowed faintly blue, a temporary breath of warmth around a world locked in long cosmic winter. The Sun's core burns at unimaginable temperatures. Deep at the Sun's center, temperatures rise above 15 million degrees Celsius. Here, hydrogen atoms are forced together under crushing pressure, fusing into helium and releasing immense energy. That energy can take hundreds of thousands of years to reach the surface. Once free, it crosses space in just over 8 minutes to reach Earth. The Sun's gentle light hides a heart of extreme heat and constant fusion. Uranus has a faint and tilted ring system. Saturn's rings may steal the spotlight, but Uranus has rings of its own, 13 known so far. They are dark, narrow, and difficult to see. Because Uranus lies almost on its side, its rings orbit at a steep angle, appearing vertical from certain viewpoints. Some are sharply defined, likely shaped by small shepherd moons. They were first discovered in 1977, when they briefly blocked the light of a distant star, quiet shadows circling a sideways planet. The heliosphere is a magnetic bubble created by the Sun. The solar wind streams outward in all directions, inflating a vast magnetic bubble around the solar system. This structure, the heliosphere, acts as a shield against high-energy galactic radiation. Its shape shifts with solar activity and interstellar pressure, stretching far beyond Pluto. As the Sun moves through the Milky Way, this bubble moves with it, enclosing planets, comets, and distant debris. The heliopause marks where this protective shell finally thins and fades. Mercury helped confirm Einstein's theory of gravity. For centuries, astronomers noticed something odd about Mercury's orbit. Its closest point to the Sun slowly shifted in a way Newton's laws couldn't fully explain. In 1915, Einstein's theory of general relativity solved the mystery. Massive objects like the Sun curve spacetime itself, subtly altering planetary motion. Mercury's behavior matched Einstein's predictions precisely, one of the first confirmations of his revolutionary idea. A scorched little planet helped reveal how gravity truly works. The Moon governs Earth's tides. Earth's oceans rise and fall mainly due to the Moon's gravitational pull. This force creates bulges on the side facing the Moon, and the opposite side as well. As Earth rotates, these bulges move, producing tides. The Sun also plays a role, strengthening or weakening tides depending on alignment. These forces don't just move water, they subtly flex Earth's crust and slow its rotation over time. The Moon pulls silently, and the oceans respond. There may be an undiscovered planet beyond Neptune. Some distant Kuiper belt objects follow unusual, clustered orbits. Their paths suggest the influence of something unseen. One hypothesis proposes a hidden world, often called Planet 9, several times Earth's mass, orbiting far beyond Pluto. If it exists, it would take thousands of years to circle the Sun once. No direct detection has confirmed it yet, but searches continue. If found, it would reshape our understanding of the solar system's outer frontier. Callisto may hide an ocean beneath its ice. Callisto appears ancient and heavily cratered, a quiet moon compared to Europa or Io. But beneath its icy shell, a deep ocean may exist. Magnetic data from the Galileo spacecraft hinted at a conductive layer consistent with salty water. If confirmed, Callisto would join the growing list of ocean worlds. Beneath ice and time, a dark sea may lie undisturbed. Venus is hotter than Mercury. Despite being farther from the Sun, Venus is the hottest planet in the solar system. Its thick carbon dioxide atmosphere traps heat in a runaway greenhouse effect. Surface temperatures exceed 460 degrees Celsius, hot enough to melt lead. Mercury, with no thick atmosphere, loses heat quickly instead. Venus's heat is not about distance. It's about atmosphere and trapped radiation with nowhere to escape. Saturn's rings are mostly ice. Saturn's rings are made of countless individual pieces, mostly water ice, ranging from dust grains to house-sized chunks. They orbit in a thin, flat plane, shaped by gravity and nearby moons. The ice reflects sunlight brilliantly, making the rings glow from afar. Within them are gaps, waves, and delicate structures, an ever-changing system of frozen motion. Ceres is both asteroid and dwarf planet. Ceres resides in the asteroid belt between Mars and Jupiter, yet it stands apart. Large enough to be spherical, it qualifies as a dwarf planet. Observations by NASA's Dawn spacecraft revealed bright salt deposits, likely left by evaporating briny water. Ceres may even harbor a muddy subsurface layer. Neither full planet nor typical asteroid, it's a hybrid world, a preserved fragment of planetary beginnings. Mars is red because of rust. Mars owes its color to iron oxide, rust, coating its surface. Over billions of years, iron-rich dust reacted with oxygen, creating its signature hue. This dust spreads everywhere, tinting the sky during storms and blanketing the land. Though darker rock and ice exist, the red dust dominates from afar. A cold desert world, stained by oxidation. Sunspots are cooler regions on the sun. Dark patches on the sun's surface are not cold, but cooler than their surroundings. These sunspots form where intense magnetic fields suppress heat flow. Some grow larger than Earth and follow the sun's 11-year activity cycle. Though darker in appearance, they remain incredibly hot. They are magnetic scars, briefly revealing the sun's restless interior. Uranus was the first planet discovered by telescope. In 1781, William Herschel spotted Uranus through a telescope. At first, it seemed like a star or comet. Further observation revealed its true nature, a planet beyond Saturn. It expanded the known solar system and marked the beginning of modern planetary discovery. Uranus quietly changed how humanity maps the sky. The solar system is about 4.6 billion years old. By studying meteorites and ancient rocks, scientists traced the solar system's age to roughly 4.6 billion years. It began as a collapsing cloud of gas and dust. The sun formed at the center, while remaining material clumped into planets, moons, and debris. What we see today are survivors of a violent, chaotic beginning. Vesta has layers like a planet. Vesta isn't just an asteroid, it's a protoplanet. It has a crust, mantle, and dense core. This means it once grew hot enough for internal layers to separate. A massive impact exposed parts of its interior, freezing them in time. Vesta is a planetary building block that never fully became a planet. The moon experiences quakes. Though silent and still, the moon occasionally shakes. Moonquakes can be caused by tidal forces, temperature changes, or meteorite impacts. Some last far longer than earthquakes on Earth. Data from Apollo missions first revealed these subtle tremors. The moon has no plate tectonics, but it is not entirely asleep. A solid world with a quiet, pulsing heart. Triton is not an ordinary moon. Neptune's largest satellite moves in a retrograde orbit, circling its planet in the opposite direction of rotation. This unusual motion suggests Triton was not born beside Neptune, but was captured long ago from the distant Kuiper belt. That capture was likely violent, reshaping Neptune's system and generating tidal heat within Triton itself. Today, faint geysers spray nitrogen into space, forming wisps above a frozen surface etched with strange, cantaloupe-like patterns. Triton is both a relic of the outer solar system and a world transformed by an ancient gravitational embrace. Neptune is accompanied by 14 known moons. Far from the Sun, this deep blue planet is surrounded by a scattered and icy family. Triton dominates in size and mass, while smaller moons like Proteus, Naiad, and Larissa trace narrow, irregular paths through darkness. Many are thought to be captured wanderers, others the remnants of collisions long past. Together, they orbit a planet shaped by migration and quiet instability at the edge of the Sun's reach. The Parker Solar Probe is flying through the Sun's atmosphere. Launched in 2018, it is the first spacecraft designed to enter the Sun's outer layer, the corona. Shielded by carbon composite, it survives extreme heat while moving faster than any object humanity has ever built. With each close pass, it gathers clues about the solar wind, magnetic fields, and the mystery of why the corona burns hotter than the surface below. It does not merely observe the Sun. It drifts within its breath. Some meteorites on Earth once belonged to Mars. Over millions of years, powerful impacts launched fragments of Martian rock into space. A small number crossed the vast distance and fell to Earth. Scientists recognize them by matching their chemistry to data gathered by Mars missions. Inside some are tiny pockets of Martian air, sealed long ago. These stones are messages from another world, delivered without intention, long before humans learned how to send probes of their own. The Sun is mostly hydrogen and helium. Nearly 70% of its mass is hydrogen, with most of the rest made of helium. Deep within the core, hydrogen atoms fuse into helium, releasing the energy that warms Earth and lights the sky. Only a trace of heavier elements remains, forged in earlier generations of stars. Despite its brilliance, the Sun is simple at heart: gravity, gas, and nuclear fire held in balance. Earth's gentle tilt creates the rhythm of seasons. Tilted by just over 23 degrees, our planet receives sunlight unevenly through the year. One hemisphere leans into warmth while the other rests in shadow, and then they trade places. Without this tilt, seasons would fade, and life would follow a very different rhythm. A small angle, quietly shaping climate, growth, and time itself. Jupiter's magnetic field is immense. Its magnetosphere stretches millions of kilometers into space, so large it would dwarf the Sun if it were visible. Powered by currents in Jupiter's metallic hydrogen interior, it traps particles, fuels brilliant auroras, and creates radiation belts fierce enough to challenge spacecraft. Within it, the solar system's most powerful planetary magnetic forces quietly unfold. Planetary rings are not eternal. Though they appear timeless, rings may be temporary features, lasting only millions of years. Formed from shattered moons or lingering debris, their particles slowly drift inward, pulled by gravity and collisions. Even Saturn's luminous rings may one day fade, leaving behind only memory and motion. The Moon preserves the past. Without wind or rain, its surface changes at a glacial pace. Footprints left decades ago may remain for thousands of years. Ancient craters record impacts from the solar system's earliest days. The Moon is not just Earth's companion, it is an archive, quietly holding time in place. Some icy moons may hide warm oceans. Beneath thick shells of ice, moons like Europa and Enceladus may shelter liquid seas in contact with heated rock. On Earth, similar environments support life without sunlight. If such vents exist elsewhere, these hidden oceans may be among the most promising places to search for life beyond our world. Sunlight reaches Earth in just over 8 minutes. Photons born in the Sun's core take hundreds of thousands of years to reach the surface. Once free, they cross space swiftly, arriving at Earth in moments. When you feel sunlight on your skin, you are touching light from the very recent past. Europa's ice may move like continents. Cracks and ridges suggest the surface shifts, breaks, and reforms, driven by Jupiter's gravity. If true, Europa may share a rare trait with Earth: active, plate-like motion. A frozen world, slowly stirring. Saturn is lighter than water. Composed mostly of hydrogen and helium, its average density is low enough that, in theory, it could float. Vast, soft, and fast-spinning, it bulges at the equator and flattens at the poles. A giant shaped by motion more than solidity. The Sun is not always calm. Solar flares erupt without warning, releasing energy that can ripple through space and disturb satellites, radio signals, and power systems on Earth. Our star protects and provides, but it also reminds us of its restless nature. Auroras follow the Sun's rhythm. As solar activity rises and falls in its 11-year cycle, auroras brighten and fade. Charged particles dance along Earth's magnetic field, painting the sky with quiet color. Space weather made visible. Comet tails always face away from the Sun, driven by solar wind and radiation. Their glowing streams point outward, tracing invisible forces through darkness. Light revealing motion where emptiness seems still. Some moons were born from collision. Earth's moon likely formed after a colossal impact, its debris slowly gathering into a companion. Others were captured, pulled gently into orbit. Every moon carries a different origin story, written in gravity and chance. Voyager 1 still whispers from between the stars. Launched in 1977, it continues to send faint signals from interstellar space. Each message takes over 20 hours to reach Earth. A quiet voice from the farthest edge of human exploration. The Sun circles the galaxy. Once every 200 million years, our solar system completes a slow orbit around the Milky Way. We drift through clouds, arms, and darkness together. We are not standing still. We are traveling. And so our journey slows. From burning stars to frozen moons, from drifting rings to hidden oceans, we've moved gently through the solar system, one quiet thought at a time. If your eyes feel heavy now, that's perfectly fine. Let the universe fade into the background. The stars will still be there when you wake. For now, rest. You've traveled far enough. Good night, Crescent Moon.